All right, then we'll definitely start. I think we see a lot of people joining in as well, but that's fine. This session will be recorded, so you can always watch it out later on. But I strongly suggest that you guys stay put with me because I really like the interactive session than just one-way session. It's important that we talk because there are so many online sessions nowadays. It's just becomes monotonous. How about we just become friends? You guys share your idea with me, and I would be happy to just talk about them. So today's session, thanks to SolarWinds, we are going to talk about 5 things to know for MongoDB performance tuning. Now, I have titled this thing as a 5 thing, but please note that we are not going to go with only 5 things. We are definitely going to talk about more than 5 things as well. The title per 5 is just a number. We might end up learning 10, 15, who knows how many. Yeah, all right then. So let's start with what we really wanted to cover in this session. I have a very interesting story to tell you guys today. The first we'll start, even though I have agenda on a thing, I'm not going to read that because you can read it yourself. But the way we have structured this thing is a very interesting way. We'll talk about some of the concepts which are very, very critical for MongoDB. Those are a little bit theoretical, but that will be done very soon. Right after that, I want to show you a super interesting demonstration about MongoDB. And let me tell you the little bit brief about what I am thinking about covering in this demonstration. And what I'm planning to cover is, do you really know which are the column you should be using when you create your index in MongoDB? I mean, we all know we should be creating indexes, but do we really know which index? Like, let's take example that you are looking for 2 columns, like column A and column B. Do we really know which column should be first and which column should be second, and why actually, and what makes decision between them? That's interesting demo, isn't it? We're going to see that today, and also we will try to learn how we can simplify that and learn right thing or self intuition, because every single time we cannot make a decision, our MongoDB is going to run on a system which is going to have a lot of queries. If there is one query, we know what to do. If there are 1,000 queries, how do we know? Well, just stay tuned. We'll be just learning in less than 30 minutes. So, yeah, that's what we want. We are going to do it. I hope you guys stay all the way till end. And let's talk about some of the things about indexes, right? So we start with the indexes. So do you see the single key indexes, compound indexes, covered query and indexes, index intersection, query with sort, index maintenance, explain plan. Now this is what I want to cover, but there is no really theoretical way to explain you. So instead of just covering a theory, what I'm going to do is I am going to go jump to MongoDB instance, which I've installed, and we'll talk about it. And then I will pose a very interesting question to you guys. So I think this is where our conversation thing will start. You can always write to me in a Q&A. Q&A is definitely for questions and answer, but don't worry about it. You can just answer your thing there as well, what I'm going to ask. And that way, it's fun. That's the entire goal. I mean, who wants to just get bored with a single thing? So very soon, I am going to share my screen with you. Here we go. So here, that is good. And I am sharing gonna click on it. And I hope you guys can see the screen in a second. All right, then. I hope you can see the screen right now. And this is a MongoDB Compass. And oh yeah, a couple of the questions has already came in. And one of the question is that, what version of this MongoDB am I using? I'm using actually the latest version of the MongoDB, but whatever I'm going to cover, it is actually good for all the versions, has been out there nearly in less 3, 4 years. Actually, I prepared this demo many years ago and still works exactly the same way. So I believe it's going to work the same way also for the future version. This MongoDB Compass is a brand new, it's the latest MongoDB Compass. So yeah, there we go. Now I want to show you about the documents which I have. So you can see there are so many documents. This is just a movies database. I have created a fake, or we can say sample. Fake is not a great word nowadays. So we'll say a sample database mflix, and here is the movies database. Now this is the MongoDB, right? And right now it's displaying 20 rows. But actually, in this one, there are so many rows. So what I'm going to do is that I'm going to remove the filter. After removing the filter, hit on find, and there we go. You can see it has around half the million rows, well, a little short of half million because it says 470, isn't it? Yeah, so that's it. So it has that many rows there. So now let's do this thing. We are going to write a query over here. So I have already prepared the query, which I am going to run. So give me a second. And the query is very, very simple. So look at the query, which I'm pasting right now on the screen. Yep. All right. There is one more question just came in while I was talking about it. Is that why do you call it a query? Well, I mean, so MongoDB does CRUD operations very, very well. I've compared this thing with a lot of other databases, and MongoDB is amazing in just retrieving the data. So there we go. So here are the three filters which we have put it in. I can definitely use a command prompt, but command prompt sometimes it can get confusing and it's so hard to navigate. So we are going to use MongoDB Compass. But if you are in the real world and if you're going to use any tool, I strongly suggest that use command prompt because it's faster. It's more natural and intuitive to all of us, isn't it? I use that all the time. But still, with that said, let's continue using this compass right now because it's a visually pleasing. So now I have three filters here. So first of them is the votes, a second one is on a year, and the third one is in custom call. Now I have this much, give me 1 second. Wow, you guys are extremely active. So many questions. I really like it. But yeah, so one of the questions is that would I be sharing the query at the end of the session? I would be sharing the queries. But the point here is that it's not the queries, it's the understanding what you're going to walk away today. And you're going to like that. So here, I think the question for all of you, this is the question. Do you see there are the three filters over here? The first one is on a votes, the second one is on a year, and third one is on a custom column. Now, I am going to hit enter, find over here, and there we go. We have a single record over him. Now, because this is just a single query, this is my demo machine, it doesn't take long to retrieve this data. But in reality, this query takes a lot of time to retrieve the data if it is somewhere else. Because look at the size of the total size is 556. It's a half the gigabytes. And if I just remove this particular query and hit run, and you can see that it says so much data. While it's fetching this data very, very fast, let's go and check one thing, and which is called indexes. So I come over here and indexes, and I see what is it doing is that it's using the index on a column, which is tomatoes or custom call. And this is the index it is being used. How do I know this index is being used? Okay, because I see number 14 over here. And when I hit refresh here, you can see it's increasing. Now it's 19, now it's 21, 23. And what is I'm finding it extremely funny is that even though I'm running it only once, it is increasing the number twice. Can you guys anybody has any idea how come this index is being used twice when I am writing a single query? Look at that. The documents here, it is retrieving only single document. How come this query is hitting this index twice? That's interesting. All right. Only way to know all this thing is if you click on the explain. So let's go on explain over here. And now click on execute explain. Now here we should be able to see what it is actually doing it. Now first it's fetching the single row, index key examine is 1, document return is 1, document examine is 1, but that is where it is doing the scan. And in a scan, we can keep on looking at, and it says, oh yeah, I use custom call, and that's the index I use. Is it multi-key? No, it's not a multi-key, and it's just one single index, and that's a tomatoes.custom call. It's being used, and it's using the second version of it. It's doing seek over here, and it's also doing the fetch, And during the fetch, it's also checking the key patterns, and that's what it is. So there we go. That's one of the reason why it is doing multi-scan. Now, this so far everything is fine. Now, my question to all of you is that, do you think this index is perfect, or should I modify this thing? Guys, so the person who answered the most question, I will have a surprise for them eventually. So please go ahead and paste your questions in a Q&A. I love this kind of conversation, and you guys are here to talk to me, just not to be there. Yeah, so go ahead and write in a Q&A. I'm reading every single thing, so don't worry about it. And now, let's do this thing. Which index is optimal for this filter? Now, please understand, I am going to walk you through the very interesting journey. Now, what I'm going to present to you is going to pose a very interesting problem also, and that problem we cannot easily solve it. And for that, I have a very interesting tool and suggestion for you. And that when you explore it, you're like, oh yeah, I wish I knew about this particular thing, tool, or method earlier. Otherwise, why am I even working with MongoDB now? So now, all right. So one of the person says, yeah, you should have all three columns in an index. That's a great suggestion. That would make it a covering index. One person is saying, can you just show me the row JSON? Here you go. Visual tree is good, but you can always go to JSON and see what else it's doing over here. So that's a row JSON for you. It's the same thing, but I usually like the visual tree. Okay. So now one person is saying, can you just analyze the schema? I can analyze the schema, but that's not going to give us a lot of information. I totally get it where you are going right now. Your point is, I want to see what are the data type probably. That makes sense. If you go to tomatoes over here, we have a custom column, and it's definitely type of the string. Now, if you go to IMDb and see the votes, it's type of integer, and here is definitely integer. But if you want to still see it, it will be somewhere here. All right, I will even have to find it. All right, I'm not seeing it, but oh, here it is. It's integer 32. There we go. So that's the answer for us. So now, if you go on explain plan, here is the index which is used. Now I'm going to do a very interesting thing. What I'm going to do is that I'm going to drop this index, which I had created. And I'm going to drop this. Here we go. Index is dropped. Now, what do you guys think? Which index this query will use? There is only single index. So if I hit refresh over here, and look at that. Nope, it's not using, I guess, any index. Even though there is a result coming out, it's not using any index at all. And that's what it says, where you use the following index. This is, I think, the information from the past. So we'll try again. Yeah, there we go. No index available for this query. That's why it's just going to examine 500,000 records and then going to show you detail, and it took half the second. That's cruel. Actually, honestly, that's super cruel. You can't let this thing go. So now we are going to create index. Now we know that definitely we can create index on a custom column, but I am going to take this column out. So now we have only two things, votes and year. With keeping votes and year, I'm going to hit find. Let's see how many records it gets me, 20 records. Let's see explain, same thing. Yeah, we have to do explain one more time. It says, yeah, I'm taking so many rows, but I'm still examining 500,000 rows, almost 500,000. How do I optimize this one? So question for all of you. I have a 6 suggestion in front of you. I can't go to all of 6, but I'm going to take two most popular suggestions, which I got it. So first one, you guys are saying create index on votes. So I will be creating index on votes. So I will call it votes. So here we go. I will find the votes here and will create it. Here we go. Votes is there. Select the direction. And the suggestion is that don't create only on a votes, create on other one, both the one. So I created on a year. Now I created on a votes and year, both of them, hitting create index. Index is done. All right, it's just compound index where you can see that. And now if I go back and hit find, all right, it definitely find it. I go explain, I hit explain one more time. And yep, it's definitely using our index, votes plus year. And you can see that index consumption over here. I hit refresh. It's great. It's moving. It's moving 2 times as we have seen earlier. Now, what will happen if I create another index? But this time, I'm going to put year first and what's as a second one? Now, if I have an index like this, right? Please pay attention what I'm just doing. This is the question for all of you. We have 2 indexes, what's in year and what's. If I run this query, do you think this number 11 will go more or this index will be used? Which of this index will be used by our query? What do you guys think? I'm going to just count to 10 and see any of you get a right or wrong answer. Let's see, 1 to 10. Okay, I counted 10. Yeah, okay. So let's see if any of you get the right answer. All right. I see mixed answers. Some people are saying the one on the top. Some people are saying the bottom one. One person said, I think year one would be better because it's outside. It's not a nested document, JSON. And yeah, I see what you guys are saying. Fantastic. Love this conversation. Now, let's go back over here and hit the documents, hit find, and it's finding. Okay, so it's found it. It's very quick. Go to explain, 0 millisecond, because it used the index what's in year. When I come back over here and I hit refresh, look at that. It's used this index. Even though I created year and what's, it did not use it. Isn't this funny thing right now in front of us? What do you guys think is the reason behind it? All right, let's see. Okay, so one person is saying this is because this index was created first and this index was created second. That's why MongoDB is using this index. All right, I like your way of thinking. Let's see how true that is. So what I'm going to do is that I am going to drop this index, what's in here. Let's drop this. All right, I like this one part of this. Let's remove the space from the end and hit drop. That index is gone. Now, let me go to documents and hit find. All right, now I will go and check. Oh, yeah, it seems like this index is going to use. Yep, it's being used. You see that? It's being used. Good job. So this index was always good index to be used. But because this was second created after this time right now, the first column is year and the second column is votes. But then this was the previous index had a votes and year, and that's why that was being used. And I think the theory, which I got it from you guys, was this is because that index was created first. So now this index is created first and it's being used. So when I hit create, and now I'll create another index, which I'll call it votes. And I'll select the votes as a first index. All right. And then I will go here. Let's see what happens. Guys, this is what you guys do in a daily life. And that's what I'm trying to simulate. And let's see what happens now. Actually, not you. Even I do the same. We trust the tools which we are provided with. This is an amazing tool. If we didn't have the compass, then we would be using the command prompt. And this is good too. But are they telling us the truth? I don't know. So I'm going to give you guys one more second again. And I want to see if you guys can come up with the right answer. Which one do you think will be used the first? I mean, that one on the top or second? Now, as per our theory, this index which is being used should be continued to be used, and this index should not be used at all. Well, let's see if that is true or not. I'll go over here, hit find, go to indexes, and let me just hit refresh. Look at that. That was the right theory, isn't it? Look at that. This one is being used right now because the one which was originally created is going to be used continuously. This is very interesting behavior, and that's why I see a lot of people often getting confused with the MongoDB. They're like, if you go on Stack Overflow, people creating very similar column index, and then they find my second index is not being used. Well, this can be any reason, but as you can see right now, this query is using year and votes, and that's what it's going to continue using it. And it finds it more efficient. It was created before, so yep, see, MongoDB continues to use it. Now, so far everything is good. Now my question to you is that if this is good index for the query which has votes and year, or what happens if I change the order over here? Let's see what you guys have to come up over here. Now I change the order. Does the order of how I want to do the search really impacts my results? Yes or no? Result is going to be same. Yes, that's true. I think, okay, one more person says, now your index will not be used the same. Okay, and he also mentioned the reason, but I'm not going to tell you reason right now. Let's see what happens. Nope, that doesn't matter at all. The reason I didn't tell the reason which was provided to me because that was wrong reason. Now we have the right reason. I think it doesn't change. So this is how the compound index actually works, and that is how the compound index sometimes confuses people when they add more and more column to that. But now the fun begins. I'm going to ask you one last time. What I'm going to do is I am going to put my original query back and see which index this query will use. And I want you guys to even give me help here. What do you guys think which index this query will use? All right, coming back to indexes, I hit refresh. There we go. It's still going to continue using the new one. Now, what happens? Now, this is where our test is. I have created something called custom call. So I'm going to say that. And now I will just say custom. Here it is. I will create this single column index. Now we have an interesting situation, isn't it? We have this one index, which is in front of us, and we have two more indexes over here. And this indexes has been always popular. Which index out of these queries will be used? What do you guys think? Again, I give you a 1 minute to come up with the answer, 1 second to come up with the answer. And then let's go and check it right now. The answer is, oh, it did not use the cover index. Isn't that funny one? Okay, a lot of you guess, I think at least 10 of you guess that the original index is going to continue using. Not the case. MongoDB switched from this one to this. Now, previously, the columns were the same, but because I just created a new index, and that is the latest one, MongoDB is using. No, that's not true. It is using them because we go to explain plan, and previously it was returning 20 documents to examine and 20 keys to examine. When I hit explain, now MongoDB has to do amazingly little work, and that's the reason it is using them. MongoDB, in previously there was a tie. Here it was a tie. Last two was tie. So MongoDB is like, yeah, I'm just going to continue using what I was using. But if you don't have a tie, in that case, MongoDB now would just go and use the index which is the most efficient. And in this case, this was the most efficient. That's why. Now, the last thing before I move to the next concept, I'm going to drop this one. Now I dropped it. Now, what you guys think, which one of this will be used? Now it's confusing, isn't it? If you guys thought you knew MongoDB, it has been teaching new thing every day. So I'm like you. Every time I see it, and I was like, oh yeah, I didn't know this thing. I had no idea. It's once again fall back to the original one. That's how it is. So original, in that case, it is totally fine. Now, all right, so one question, okay, I'm just going to take a question for a minute before I'm going to show you. Okay, so the question is that, how come you, okay, there are three questions. So question number one is, can you create an index with all three columns and I want to see it? All right, that I will create. One person is saying, can you use IMDb votes? Okay, so he has given me here, I know his names, that's why I'm saying he has given me very clearly the names, which is votes, year, and his point is, then add a custom here. Let's see if this index get used or not. Okay, fair. I will try this one. And the third one is that you have presented a very unique problem. This seems like my query doesn't change, but index keeps on changing. Or when I change my query, the I don't know which index will be optimal. How do I know what is right and wrong? Great question. I like your third question. I'm going to park it because after 2 minutes, we are going to switch gears and we are going to learn something super cool here. And that is what you will like. This is just a problem, but every problem has a solution. Otherwise, why would I even be presenting here? Okay, good then. Let me just finish the creating index. I think this is unique problem. Let's see if this index is being used or not by this query. Let me hit find. Up. All right. Let's go over here and hit refresh. Yep, that is definitely used. So please understand, now for our query, this has become a covering index because it has all the three fields which we have in our filter over here. That's the reason MongoDB has switched from this to this. Now, what I can do is that I can remove this again, and the fun game begins because now I have only two, and for these two, I have last two as a covering index. Let's see which one is being used now. And you may be in for surprise. It's all back to the original one. So there we go. So now we have learned three things, which I'm going to just very quickly summarize before I go to the next topic, which I want to do it. So I think the question, which is how this problem is there. So the way the MongoDB uses, it's try to go to use the covering index. In case of the covering index, there is a tie, then it will use the one which was created the first. And also, even though sometime when there is no covering index, at that point of time, MongoDB will go and use the index for which it has to do the less work. That's awesome. Now, how would you know this kind of situation is being built? Because the queries which our users are running, it's not in our control every time. So what do we do? How do we figure that part out? And that's the point I want you guys to help me out with them. So let's do this thing. A very simple experiment, which we will do now. So, all right. Now, I'm going to open my browser in front of you. Okay, so, and there we go. Okay, so this is a fantastic tool which I just wanted to bring to your attention, and that's called a DPM. It's definitely from SolarWinds. Yeah, so yeah, but this is doing a very interesting thing which I want you guys to see it. So there are so many things I can say about this tool, but I want you to pay attention to this one thing because this one thing solves my biggest problem as a consultant. See, I'm a performance tuning consultant. I go to my client's place and I sometimes have no control. I just have no idea how do I help them out. There are so many queries. Each of the queries might have a different pattern and different thing it is doing. How do I know what is the right thing or not? So if you have properly configured DPM, which actually supports MongoDB and a few other databases, that conversation we will leave on a side for a moment. It supports them and it tells us a very important thing, and I want to show you that. So let me just go to alerts right now. Here you can see there are various alerts. Now, along with the alerts, we also have a charts, and under charts, there are so much metrics. Now, these metrics, you can watch and learn about them, but we are a least interested right now in any of them. So these are some of the sample queries. And under charts, under dashboards, let's go to metrics. And, oh, yeah, 1 second. I need to show you something more fun. So let me just get back. So first thing what you can do is that we can just go and find our query over here. That would be so simple for us. We can just go and type in our query and see what our query is doing. Or we can do this under health. If you know which query is bad, you can do that. But what happens if you do not know which query is bad? Then you can just go to health, and over here, there are three things: false, events, and best practices. We'll start with the best practices for a second. look at that, what's going to do it to us. There are two things. One is agent configuration, but second thing is where I want you to look at it. It says MongoDB index analysis, and it has one recommendation and two occurrence. Let me expand this. It says this query could benefit from an additional index. Now, this is what I wanted you guys to pay attention, because then it will tell us that first time when there was an index missed for a query. So this says first time it was missed 12 days ago, and last time it was just missed a few seconds ago. So if you create an index on the query like this, there is a very similar query over here, then it will improve its performance. So let me just show you something. Either I can mute and go away, or I can just click over here and start seeing more information. This is what I'm calling it fun, because you know what? When I go as a consultant, it's impossible for me to just say, yeah, just create these 5 indexes. People come and hire me and say, can you just create 10 indexes? And I can say, do you know which queries are bad? If you know which queries are bad, I can easily create index for you. But if you are not sure which queries are bad, then I cannot do anything for you. I am in trouble. That's where I need to depend on this kind of third-party tool, but so helpful. Look at that. I clicked over here because this is the 4th time this query ran, and it says, look, it is the explained plan. And I click on index analysis, and this tells me, you know what, why don't you just go ahead and create this index, and this would help us to get us better performance. And also, for the same query, we can see the latency, total time, how many times it has done, how many times the index was missed, and other details. It's just there in front of us. So this is what I like it really, really cool. Okay, so you go over here. Let's quickly see the second index, because I mentioned to you the problem, right? This is the solution to that problem. And if you know the query, you can do all this kind of thing yourself. But if you do not know query, look at in this scenario, it has been issued 42 times, and this was also logged into slow query, and it is pulled out of that one. So you can do all this kind of thing. And now let me just click on one of them. I'll just click here. Yeah, this looks like okay. Yep, this says, yeah, this is where the excellent issue is there. Okay, why don't you just go ahead and create this index? When you create this index, your performance will go to the next level. So this is how you can solve your key problems if you know how to use the efficient tool. Now, I want to talk about, so indexes is super critical. Make sure you maintain them. There are so many things you can do with indexes. But again, we'll come back to this. So I have a couple of more things to talk about it, and we'll come back. And I see some questions also, so I'll get back to that. So let me just cover a couple of other important parts. So we talked about how the compound indexes, single key indexes, cover one, as well as we talked about how there was a query which was using 2 indexes, and maintenance part also explained, we talked about in detail. So another thing which I want to talk about is the database state. This is what is being ignored by most of the people. I want you to do this one thing, okay? Why don't you go to your MongoDB instance and just run db.run command? Because when you do this kind of query, it pretty much tells you everything which is right and wrong for your system. I mean, it tells you so many things that you would be like, oh yeah, I wish I knew all this kind of thing. Because it gives you the information about your server, it gives you about version, it tells you about uptime, what are the connections, how many connections available, and most important thing, it also talks about page faults and OP counters. So hold on, how about this? If I ask you, do you know to your MongoDB how many connections you have connected right now? Do you even know how many there? How many even available more? How many total kind of connections you can do that? Now this kind of information is super, super critical for us to know, but we do not know. Many times we do not know. And another critical thing is about page faults, right? I mean, do we know of page faults? I mean, how many page faults are happening? And page fault is one of the most expensive thing can happen on MongoDB server. So if you are not taking care of the page faults, or if you are just keeping a blind eye, what's the point about even tuning your system? And now this kind of information will be just thrown to you immediately if you run the command like this. So either you need to know, all this, like connection page faults and various counter, or you can do other tricks, but we'll talk about other tricks a little bit later on. So that's one of the things. Now, MongoDB has standardized the White Tiger storage engine. When I go in a recent version, you can use other ones too. So when I go for performance tuning consultation, one of the biggest problem which I see right now is that people have no idea about how to configure the storage engine. So White Tiger internal cache size should be set larger of either like 50% or total RAM minus 1 GB. Now this I see violated so many times. People will just be happy with the default 256. You have a 10 or 20 gigabytes of the machine. People install MongoDB on the top of it, and they never go and reconfigure the cache sizes for that. I think this is one of the cruelest thing I've seen it, and I strongly suggest that we go and look into it. So if you are a MongoDB administrator, you would definitely will share this recording as well as slide deck. But I would just at least wrote down that I'm going to look into the cache size in a gigabytes and see if it is not set to the super low value. Because document level concurrency control for write operation is super critical, and that is where you need more memory. Now, so this is a critical part, and I just see a lot of people just missing that one out. So first of all, either you should know every single configurations, or you need to depend on something else. So let me just show you something first. I'm going to go back and switch to, before I go, so demo, which we are seeing anyway. So we are going to look at this demo. We are anyway looking at. So now let me switch to the demo part, because now we have official slide of demo. Yeah, give me 1 second. I'm going to show you something fun. The demo is there for sure, but okay. Now what I did is that I'm going to bring back the command prompt, because we talked about how command prompt is great and things. Well, it's great. I use command prompt all the time. So when I look at the command prompt, and over here, this is the information which you are seeing. These are all actually output of my run command. And it's not even verbose, okay? It's not even verbose. It's not like everything right now. It's only going to show me few of the things which is there. So yeah, that's how it is. So look at this. It talks about so many things. So it says currently I'm using only 3 connections, and I have 497 connections are enabled. I mean, I hope you can see this part, the one which is highlighted. So isn't that thing is cool? Like, I mean, yeah, a lot of people don't know even about this one. So even have you paid attention to this part? This is cool. This is important. And it says right now I've paid for 0, because this is a demo machine which is really not running anything production. But yes, you can definitely run this thing and figure it out yourself if your system is doing huge amount of the page fault. If it is doing it, that's something you may want to pay attention. Now my question to you is that a lot of places I go for consultation, and I ask them, sir, what kind of workload you guys running? And people always say, oh, we are very read heavy, or we are very insert heavy. My question is that how do you even determine you are read heavy, or how do you even determine you are write heavy? I mean, how? And the answer is very simple. If you look at the op control replica over here, the op counters for the replication, if you have configured the replication, it will tell you that what is being replicated. And if it's not op replication, then you can check for your primary system over here. Look at that. It says there was insert around 447, queries ran 57, and no update and delete right now. But get more was 77, and there was various commands ran around 6,000 times. So yeah, there we go. So this kind of thing, these are the important thing. I like to say these are the critical thing which people sometimes do not pay attention. Now these are just set of the counters. I mean, I can keep on going and talking about it, but how do you know when any of them go right or wrong? Yeah. So again, that's where exactly you need to go back to something which is capturing every single thing, which captures like what is your latency, throughput, concurrency, error rate, and network throughput, disk throughput, like how much memory is even you are using. You are only using a 29% of the memory. So this kind of things you need to understand. And also what happens if your agent get disconnected and things. So this is something you need to know, and that's where you can use the tools like DPM who can help you out about with the various kind of configurations as well as misconfigurations, right? You need to know what went wrong. You need to know why we are going to use something like that. You also need to understand the queries which are using a lot of CPU and the queries which are not using CPU. I mean, like, how do you go and figure it out from your system which queries are taking most amount of the CPU time? There we go. This query is looking like, yeah, I need to go and fix it. Something is happening in the logs where it is doing get more and using so much of my CPU. Just mousing over, it tells me the one which is in a red. And if I mouse over this one, it says, look at that. This is what is happening. Now, let me click over here and it's just loading this particular query. And look at that. Do you guys remember this query? This is the same query where we talked about indexing, isn't it? So you can arrive to the right answer multiple ways. You don't have to come to the answer same way. This is the same query which is missing indexes. You create indexes on the top of it. There we go. You can actually remove this particular query from your issues of the CPU. It will fall off from this list. How cool is that? So again, as I said, multiple ways to arrive to the right answer. You can also change the chart over here, and instead of total time, you can start seeing other things as well. Yeah, you can go over 1 hour, 3 hours, or 12 hours, something like that. Yeah, so that is totally up to you how you want to slice and dice and figure it out what is going on. And sometimes the query which you really want a third-party consultant to tune, that one is innocent, and you can see that easily if you just look at it a little bit. If you scroll down a while. Yep. So that's what it is. That's what I really wanted to talk about it. So dashboard is critical. You need to understand about your memories, how the memories are being consumed, and a lot of things like, for MongoDB, you need to understand the get last error weight, what kind of network it is using. If you are not familiar with TTL, delete and not using it, I strongly suggest you go and look into it. And this is the op log times and replication counter, which I talked about. And each of them, you can configure the alerts to get notified. And so, yeah, so those kind of things. And yes, we talked about the wide target cache pages. Yeah, you need to know all this kind of thing. And all of them, how many they are, and all this. And if there is any anomaly going up and down, and which query is taking how much cache and things, and all the counters at any point of time, it's just there in your fingertip. So, yep. Yeah, try it out. Give it a shot to the DPM and see if this really works for you. I can promise you one thing. I love MongoDB just like many of you do. But it's not a bad product. It's amazing product. That's why we want to use it. But it has certain limitations, and I won't call it limitation. I think what is that it's our interpretations. We come from the different background. Our business needs are different. Our computing needs are different. And sometimes we just need to understand our product more better, better, more better. There is no word like more better. We need to understand our product better and do that. So I am going to answer 2 more questions right now, and one of them is about the indexing first. But meanwhile, I strongly suggest you guys go and take a poll, which will be there on your screen on the right side. So take a poll right now and just show the express your interest, and while the poll is there in front of you. So, yep, there we go. And now I think I'm going to take all the questions and answer. I strongly suggest you ask me right now. Don't leave, because I'm going to show you one cool thing before we are all done with respect to the this one, this our conversation which we are doing. All right. So the first question, which is right now in front of me, is that how many indexes are good number of indexes for a document in MongoDB? This is a good question. Actually, usually I get this question for MariaDB, MySQL, or SQL Server, Oracle kind of thing. But this is the first time I got it for MongoDB, but I'll still answer this one. Really, there is no right or wrong answer. But I will tell you this way. If you are going to create too many indexes, you need to still understand one thing. Every index or every object which you are going to create on your table, it's going to create extra data and workload. So if your indexes doesn't fit in your memory and those kind of issues you start walking into, you will start having issues. So I suggest you go to the system profiler and find out that if there are slow queries or if too many indexes, then and then you will consider creating indexes. And this is where you need to go back to the tool like DPM, which will guide you what exactly you can do to make it right. So when to configure various profiler? Well, yes. So yeah, I'll show you the profiler a little bit later on. But when the query is ran, if the fast it's running or not, if you want to know what kind of plan it is using, where to use, and what kind of indexes to use. Now, if you really want those kind of things, then and then you can configure the profiler. Otherwise, I think configuring profiler will take extra amount of the time, and I think you should avoid it if you can. Okay, there is a one more question. Is that what happens if I create an index with 10 fields? Nothing happens technically. That field will become too big, and if that field is on a huge amount of the document, it will first of all take forever to be created. And after it is created forever, the second problem you will face is that when it's insert, update, delete happening to that index, that would take more resources from your original system. So unless you are very, very a beefy server, you will not consider that kind of thing. Oh, this is the fun question. It said, what makes my MongoDB query slow? All right, this is a good one. So I'm going to answer you this way. So really, it's us, you and me, who makes our MongoDB query slow. We write things in such a way, we don't create proper indexes, we do not configure the memory, we do not pay attention to page fault, we ignore the operation counter. It's going to be slow. And on the top of it, we put profiler there and let it run forever. So MongoDB profiler is a great thing. I really like it. But you know what? It's little expensive in terms of resources. And I'm not a big fan of that one. I actually prefer different either you write your own profiler, buy any other product. I'm not saying you buy this one product, other product which can do the profiling instead of native one, because it's still configured outside. You want your profiler not on the server where you are installing the tool. That's one thing. So yeah, that is the one thing I'm going to show you in next right after 2 minutes. I'm going to show you. So, and this is the second last question. I'm going to answer this one, and then I will show you that profiling part. That's cool. So, which is the best possible way to explain the troubleshooting query? Well, there are three ways we can do. Like we know, first is a plain vanilla explain, second one is cursor explain, and third one is DB collection explain method. Matter of the fact, all three are doing the same kind of things. Use the one whichever you find it optimal. It's not that one is better than another one. But the three things which you need to understand in a query plan are query planner, execution states, and server info. So everybody who is watching this one afterwards and not being live, well, I wish you were live because you could post me all these questions. But I seriously think you can still write an email to me and reach out and ask me more questions. Now, okay, this is the time where I want to tell you one last thing. Okay, so we talked about the execution plan, right? And explain query planner. Now, what are the things you will look in a query planner? You will look call scan, which is collection scan, IX scan, which is index key scan, fetch, which is retrieving the data, and shard merge, which is merging data, and finally, you look for explicit sort. Now, before we end this session, as I promised, I am going to show you that last and final part about a third-party profiler, which all of you are extremely curious about. So there we go. Here it is. So what I did is that we are actually back in DPM. And here, if you see the left side, the third tool is about the profiling, and this is what it does. So let me just go to summary, and then I come back to profiler again, and here it is. So you can see all this are profiler and how much query, how long the query is run, what it is, what is this count, what is this total count percentage taken in compared to the entire thing by total time. This is what is visible, and these are the queries, which is really taking a lot of time. You can see from which host it is coming, how many times it is marked as a slow query, and what is the latency. So I strongly suggest have a profiling tool, which is little different. I mean, it's on a different server, so you don't text on the original server. So that's what I was trying to say. Well, this is what we wanted to talk about. You guys been amazing crowd. So this is the link where you can go and catch your DPM. So with this, at this point of time, I just have to say one thing is thank you very, very much. Thanks to SolarWinds for doing everything. All right. So final one is that go try it out DPM, write an email to me, penal@sqlauthority.com, and you will have this video there. And go attend this video one more time and ask me questions. It's going to be fun. I love the questions, and I'm sure there is it would be challenge. It will be fun thing to figure it out what we can do with the DPM and what we cannot. We will give a task to the team and say, why don't you guys build this one because this is what we needed and it's not there. And if you just remove the host from here, and you can just see the DPM is more than just MongoDB. It can do MySQL as well as Postgres and Redis and stuff. So anyway, guys, this is the point where I would just say, write out, ask me questions. Great time. You've been wonderful audience, and I just had a blast to just talk about it. So thank you, guys.